All right, guys, next section is related rates. Now, I want to warn you, it's going to take some time to get used to these just because when it comes to story problems, there are couple different things between each story, right? Based on what we're doing. Maybe it's the shape, maybe it's just what's happening in the story. But what's always the same is the procedure that you will take, okay? So one of the other things I want to mention is that this is where one of your FRQs will probably come from, related rates. And we'll be practicing this for the rest of the year. So if you don't quite get it right away, it's okay. We're just going to keep trying at it, okay? In related rates story problems, the idea is to find a rate of change with respect to time. So this is very important, respect to time, okay? Because remember before when we were finding derivatives, it was respect to x. So what does that mean? Well, when we were doing respect to x, we didn't have to have a dx added on the end. Does that make sense? When we did implicit last time, because again, still respect to x, you attached an extra y prime on there, okay? Well, since we're doing it with respect to time, all variables that we take a derivative of has to have a hook on of d that over dt, and that's where this comes from, okay? So after we read a problem, what you want to do is draw anything that that looks nice. I mean, visuals always help. Then you want to write the given information and what you need to find, okay? Now, a couple of things we need to keep in mind, because we are then going to write any equations that will help us with the story. If a quantity is changing, it must be represented with a variable. If it's constant, it stays the same no matter what over time, you label it with a number. For secondary relationships between quantities, it might reduce what your variables are. So if you have a lot of variables going on, you might be able to find a secondary equation that you can substitute in. We're going to go through all of these. Then what we're going to do is implicit differentiation with respect to t. And then we're going to substitute in for all the given information we have, okay? Down below here are some geometry formulas or some that you might use throughout these story problems, okay? You'll see that the right triangle is really a big one we use. Another one we use a lot is the cone, okay? So let's see what we can do right here. Here it's just going to give you an example without the story. So what it does is it gives us a dx over dt equals 6. Negative 6. It gives us a y value, and we have x, y equals 12. X times y equals 12. Now, in this problem right here, you have to understand that y is not staying at 4. Y changes just as x changes. So we can't plug that 4 in until after. And what we're trying to find is dy dt. So right now what I'm going to do is I'm going to take my formula that we have, and as you can see, it's a product. So I'm going to do implicit differentiation. Remember that it happens to be the first function, which is x, times the derivative of the second function. The derivative of y is dy dt. Okay, remember, because we're doing it with respect to time. Plus the second function, y, times the derivative of the first one. Well, the derivative of x is dx dt. So with related rates, you will have a d over dt for any variable, okay? Equals, and then the derivative of 12 is 0. All right, as you can see, we can plug in the negative 6 here, we can plug in a 4 here, but we need to find this one. Well, we can only find this if everything else is filled in. So we have a y, we have a dx dt. So we need that x. Is there a way we can get that x? Well, yeah, we can get that x by plugging in the y. X times 4 is 12. So x must be 3, and y is 4. So now I'm going to plug in. We have 3 times dy dt plus 4 times negative 6 equals 0. And then, of course, we would solve, right? So negative 24, move it over, positive 24 divided by 3, that gives us 8. Now, without a story, we don't have to worry about writing a sentence or anything like that. But with these stories, we are going to be writing and practicing how to do those sentences at the very end, because those are points within itself, okay? A windlass is used to tow a boat to a dock. The rope is attached to the boat at a point 15 feet below the level of the windlass. If the windlass pulls the rope at a rate of 30 feet per minute, at what rate is the boat approaching the dock? And when there is 25 feet of rope out? Okay, couple of things I want to show you. They drew the picture for you. Okay, but you need to remember the rope is being pulled to the left, and the boat is going to the left. Left means what type of numbers, guys? Negative. The other thing what I want you to keep in mind is that because now we're going through the given information, 15 feet, the windlass is 15 feet above the ground. Does that change at all? No, it doesn't change. That's why we have 15 there instead of y. Now, the windlass is pulling the rope at 30 feet per minute. The windlass is z, right? Right, that's what it's pulling. So since it's a rate, feet per minute, I know it's a rate. That means dz over dt must be 30. Now I'm leaving a space because since I know I'm going to the left, it means it's a negative 30. Now, what we need to know is we need to find what dx dt is. So I'll put a question mark. When the rope is 25, the rope is 25, that means z equals 25. All right, so we have a triangle here. There are a couple of formulas we have with triangles. We have area and we have the Pythagorean theorem. And we're not talking about area here, so we know we're going to use the Pythagorean theorem. So I'm going to set up the equation that we want because that's the next step. This is our given information. Let's talk about the equation. So we have x squared plus 15 squared equals z squared. Now we're going to take the derivative. 2x, don't forget, dx dt. It's going to be plus 0 equals 2z dz dt. Now I'm going to circle again what we're solving for. We're solving for dx dt. Do we have the z? Yes, we have it. It's 25. Do we have the dz dt? Yes, it's negative 30. What we don't have is the x, and we need the x. Is there another way I could have found the x? Yes, I can go back to the original problem and say x squared plus 15 squared equals 25 squared. And we can solve. Now when we solve for that, we get x equals 20. So now I can plug in 2 times 20 dx dt equals 2 times 25 times negative 30. When you do that algebra out, we get dx dt equals negative 75 over 2. Now, here's where your sentences come in. And yes, it says write a sentence explaining. That will not always be the case where it will tell you to write a sentence. I want you to know when you do a story problem like this, you will always say what your answer is. Now, what I would do is always use what's given to you. So you don't just want to say, hey, the rate of the boat approaching the deck is negative 75/2. That doesn't explain it. We say when the rope, because it's at that point, right? When the rope is 25 feet, make sure your units are there. The boat boat's distance, right? Because that's what we're talking about, boat's distance. And I'm not going to say decrease, or I'm not going to say negative 75. I'm going to say the boat's distance is decreasing at a rate of 75/2 feet per minute to the dock. I get the whole story in there. I get when we are, where we're looking at, and what it is doing. Increasing, decreasing, changing, and by how much and how many units, okay? We're going to do a couple more examples, just different stories, but we're going to be using the same format every time, okay? So this one doesn't have a drawing, so the first thing we're going to do after we read it is draw it out. See if we can picture what's going on, okay? A policeman traveling south towards an intersection. So let's make this the intersection, okay? And he's traveling south. When the policeman, and spots a speeding car traveling east. So he sees a car and it's going this way. Of course, I wouldn't go over here because he wouldn't see over here, right? He sees the car going this way as it's passing, okay? So what I might want to do is you can either use X and Y just to keep it consistent, or you can use, in this case, P and C. I like consistency, so I'm going to use X, Y, and Z. You just have to remember where the police car is from the speeding car, okay? So here we created a right triangle. I'm going to keep this as Y as my horizontal, or as my vertical, X as my horizontal, and Z as my hypotenuse, because that helps me out there. So when the policeman is, okay, now is he always 0.6 miles away from the intersection? No, he's not. So I keep this in as a variable, and I'm looking at the time when Y, because that's my police car, is 0.6. Well, I know when the policeman is at 0.6, I know the car, which in this case is X, is 0.8 from the intersection. Now, the other thing, no, this is good because this is distance, and distance is always positive, right? From the car. The policeman's radar shows the distance between them is increasing. Now, the distance between the cop car and the speeding car is which variable? It is Z. So that means dz dt is 20. Now it says increasing, so we keep it at 20. If the speed of the police car is 60 miles per hour, so that's dy dt, because that's our police car, is 60. What is the speed of the car? Now, here's the thing you need to watch out for, which is not obvious. Which way is the police car going? The police car is going down, and down means what value? It means negative. Think of this. Velocity always talks about direction, right? So we have to talk about, is it a positive or a negative? Okay, and then we're going to write a sentence. All right, so we are trying to find out what dx dt is. All right, well, again, we have this right triangle. We have area, we have perimeter, and we have our Pythagorean theorem. What's going to be the best? Hopefully you said Pythagorean theorem. So we have x squared plus y squared equals z squared. Okay, none of them were constants, so we don't have any numbers in there. We just have our variables. Let's take our derivative. So I get 2x dx dt plus 2y dy dt equals 2z dz dt. Now, some of you might recognize that I could get rid of the 2's because they all cancel out, but I'm just going to keep them there for now. I'm going to circle what I remember, what I need to fill in, and I'm going to see if there's anything missing here. So I have my x right there. I have my y. I have my dy dt. Ooh, I don't have a z. Is there a way that I can find out a value of z? Yes, I can, because I have an x and a y. So on the side, I could say 0.8 squared plus 0.6 squared equals z squared. So z ends up being 1. Okay, now I can fill everything in. 2 times 0.8 dx dt plus 2 times 0.6 times negative 60 equals 2 times 1 times 20. Okay, I'm not going to do all the algebra for you, okay, guys? I'm just going to get it out there. dx dt comes down to 70, which is good because we're going to the east, so it should be positive. And of course, it's miles per hour, right? Because it's the speed. Now I need to write a sentence. Hopefully I give myself enough room. So we're talking about the car, right? The speeding car, or the car is moving away from the intersection, because that's what we're talking about. At the speed (70 miles per hour). When I'm running in a room. The police car is 0.6. See how I'm doing that? Like, I'm explaining the whole situation. And we're going to have plenty of time to evaluate your sentences to see if it was enough or not later, okay? ... because I'm running in a room. All right, let's see in the last one here. Gravel is falling in a conical pile at the rate of 10 feet cubic per minute. Now I want to show you guys something. Look at your units. Feet per minute is a rate. So we know it's a d over dt. So that's step 1. Now it says cubic. What is cubic? Volume. So I know just from that first sentence that dv dt is 10. and it is falling. So it's falling, so it's getting more and more in, so it's positive, right? Even though it's falling and you think that should be negative, it's not draining. We're actually making the pile bigger and bigger and bigger, okay? At all times, the radius is twice the height of the cone. So at all times, the radius is 2h. Find the rate of change of the height of the pile. So we're finding dh dt when the radius, so when the radius is 6. All right, this is what I got so far, right? All right, so let's do this. So we've got our equation. What I want you to notice straight off the bat, guys, is that we have too many variables. Every time we dealt with before, right, we dealt with 3 of them, but we were given enough information that allows us to break it down more, okay? But in this case, as you can see, I don't have a dRdt, and we're gonna need that, especially if we are having 3 different rates here. But is there something else I could do? Yes, right here. I can actually replace the r with 2h. So I get v equals 1/3 pi times 2h squared times h. Now be careful right here, because that 2h is squared, not just the h. So that becomes 4h squared. So I'm going to rewrite that so it looks nice. So I get 4/3, because I'm bringing that 4 times the 1/3, pi h. Well, if this is h squared and this is h, we get h cubed. Okay, this looks a little bit nicer, right? Okay, so now let's do the power rule. Remember that this right here is a constant. So we have dv dt. That scalar we're going to keep there, and we're going to multiply that 3 in front. And h squared, now don't forget, every variable has a d over dt. Okay, and of course you see that the 3's cancel. All right, so far so good. Now, what we are trying to find, right, is dh dt. Awesome. We have a dv dt right there. Do we have an h? Well, we have when r is 6. Well, when r is 6, what is h? H is, or when r is 6, yes, h is 3, remember, because it's double the height. Now we have an h we can plug in. So we have 10 equals 4 pi times 3 squared dh dt. And then we solve. What I would do, guys, is keep it in pi, because then it's nice and easy. So we end up with dh dt equals 10 over 36 pi. And of course, our rates are in feet per minute. Now, I don't say feet cubed, because again, feet cubed is not a height, it's a volume. So we have to keep that in mind. All right, so let's talk about the sentence. So when the radius is 6 feet, the height of the pile is, this is positive, so I'm going to say increasing at the rate And then you can reduce this, but you don't have to. You can just say 10 over 36 pi feet per minute. Okay, try those out.